Hi guys, welcome you all to my channel Explore Edu to Teach.
So the next topic that we'll be learning today is barrier potential and depletion region and also capacitance. We have learned variety of topics till now, talking about the introduction to PN junction diode, the diagram about PN junction diode. The video is already uploaded on my YouTube channel Electronic Devices and Playlist, so you can watch it from there. Then there is drift and diffusion is already covered. The next theory topic is going to be barrier potential and depletion region and capacitance. Please understand these concepts very well and note down the formulas. The formula sheets are going to be uploaded regularly on my Instagram page. The links are given down in the description box. Just check out my Instagram page. It is Explore Edu to Teach only. The links are given down in the description box. If you like that particular page, please follow me on Instagram as well. It's a very important page because it will give you all this formula written in a very concise manner. It can be helpful for you. You can just save those images for your reference and for your revision as well as for your studies. So we'll be talking about this. So once you understand these concepts, we'll be having one particular lecture when we are just going to solve numericals. So whatever formulas we have learned, whatever theory concepts we have learned, we are just going to apply it in the numericals over here. As simple as that. So please understand these concepts, and if you have any kind of doubt, please let me know in the comment section as well. So let's begin up with the barrier potential and depletion region concept. So if you see, we had this diagram over here, right? So this region which was formed between the P side and the N side is the depletion region, and the potential offered is the barrier potential. So if I talk about depletion region, is basically called so because it is depleted of mobile charges. That is, there are no mobile charges or no moving charges present in this region, and hence it is called as the depletion region. It is created because of the diffusion of majority of carriers across the junction when a PN junction is formed. So what happens is that if you see the PN junction diode, when the holes from the P side move towards the N side and the electrons from the N side move towards the P side, diffusion takes place and a region is formed between them. That region is called as the depletion region, and the potential offered by this particular region is the barrier potential. I hope I am very clear with this. Okay. So what is barrier potential then? So if the region is called as depletion region, what is barrier potential? So barrier potential is a potential difference or junction voltage developed across the junction due to the migration of majority carriers across it when PN junction is formed. The potential opposes the further migration of majority carriers across the junction. That is very, very, very important. So what happens is that this potential will restrict the flow of the diffusion of carriers from the P to N and N to P. The built-in potential for silicon is 0.7 and for germanium is 0.3. So the barrier potential is not directly the built-in potential. It is basically VBI, which is the built-in potential, plus VR in case of your reverse voltage, or VF minus VBI, where VF is the forward voltage. So I hope I am very clear. This barrier potential and depletion region concept is basically from the diagram which I have drawn over here. These diagrams are present on my Instagram page. You can check it over there. You have a negative immobile ions, your positive immobile ions, and the region is called as the depletion region between the P side and the N side, and the potential offered by this region is called as the barrier potential. That is very important. The formula is given over here. I'll try to document all these formulas on a short page and upload it on my Instagram page, so you can follow me over there and you can save all those copies of my images, share it among your friends. It is going to be definitely helpful for you because this subject has many formulae and that becomes difficult for students. I myself, when I was a student, I understand it's so difficult to remember so many formulas. So I'll be trying to upload it on my Instagram in a very simple manner. Just learn it from there, make a note of it. It will be helpful for you in your numericals as well. So if I have to say another formula for VBI, there are different set of formulas depending upon the information given to you in the question. You can use this formula, or you can use so many other formulas which are there. So if you know the VB, barrier potential is VBI plus VR or VF minus VBI. But what is VBI equal to? The VBI, that is the built-in potential, is equal to KT by Q into ln Na Nd upon Ni square. Now these terms are already explained in my previous classes. However, I have written it over here as well. KT by Q is equal to Vt, which is my thermal voltage. Na is the acceptor ion concentration. Nd is the dopant concentration. Ni is the intrinsic concentration. So VBI is equal to KT by Q into ln of Na, and if I just put this Nd below, Ni square by Nd is nothing else than Pn, that is Na is the holes in the P region and Pn is basically the holes in the N region. Similarly, VBI is equal to KT by Q into ln of Nd upon Ni square by Na. Nd is Nn upon Np. Nn basically stands for the electrons in the N region and Np stands for holes in the P region. So you have to remember these formulas very well. Depending upon what kind of values are given to you in the question, you can apply those formula and get the built-in potential. So remember this formula for the built-in potential, and remember even this formula and the meanings of those terms in those formula, so that you can remember it well. Again, if you remember the band diagram which we have, if I consider this as the intrinsic Fermi energy level, this is my P side, this is my N side. So ECP is the lowest energy of the conduction band in P region. ECN is the lowest energy of conduction band in the N region. Similarly, you have the valence band for P and valence band for N. So the built-in potential, another formula is also given as ECP minus ECN and EVP minus EVN. So don't get more confused. Remember what is a depletion region. A depletion region is basically the region that is formed because of the diffusion of the electrons and holes from the N side to P side and P side to N side, and the potential that it offers is called as the barrier potential. The formula is here. The built-in potential can be formed from this particular formulas. Now there is something called as the capacitance. The capacitance, you have two kind of capacitance. One is the transit, other is the diffusion. The transit capacitance basically exists in the reverse biased mode. I repeat, the transit capacitance exists in the reverse biased mode, whereas the diffusion capacitance exists in the forward biased mode. So if you see, when a PN junction is reverse biased, the depletion region acts like an insulator. Obviously, there is no flow of current actually happening. But in a diffusion, the PN junction is forward biased in case, and the capacitance formed is diffusion capacitance. So the transit capacitance is given as dq by dV, that is increase in the charge and increase or change in the voltage. It's given as also epsilon into A by W, wherein the value of epsilon is given. A is the area of the cross section of the region and W is the depletion region width. Similarly, you have the diffusion capacitance, which is given as this formula, which you can see over here, tau into I upon neta Vt. So this formula is very important. You should know it very well. So you should know about barrier potential, you should know about depletion region, you should know about what is VBI, you should know about these formulas very well, you should know this energy band diagram, you should know about transit capacitance, you should know about diffusion capacitance. Transit capacitance is reverse biased, hence acts like an insulator. Diffusion capacitance is in forward biased. The basic formulas you should be very aware about. So I hope you have understood these concepts very well. Please, these notes are present in description box of my YouTube video also. I get many pings on my Instagram saying that, sir, please provide us with the notes, and I tell the same answer. So I'm telling here very publicly, the notes of every video lecture is present in the description box of my video. Just go in the description box, you will find two things. One, the notes link of my Google Drive link in which the notes are present, and secondly the Instagram link wherein all the formula sheets, short videos are uploaded over there. It will be very helpful for your study in a methodical manner. So please refer to my description box. You will get all the notes and everything over there. So if you like this video, do not forget to like, share, subscribe to my YouTube channel, follow me on Instagram as well. Thank you so much guys. God bless.